Hi everyone, and welcome to the first live Q&A. Last week I asked you to ask some questions through Instagram, Facebook. I've posted this event and I've received a few questions, and I will get to those questions at the end of this session. But in the beginning, I'd like to show you a nice use case that was used last weekend on an event. I've had this request to control pyro effects like CO2 and confettis in a big festival here in Portugal, and we came out with a solution with StreamDeck, MA2, and some logic behind it. Basically the request was that the people could trigger these effects from the StreamDeck, and this would then trigger MA2, and because the machines were listening to ArtNet. But one of the requests was also that that was some feedback on the StreamDeck, because each artist has some time available for either fire or CO2 or a number of confetti triggers, and they wanted to show to whoever is firing these effects how much time they still have left of each of the effects. Here are some videos that I shot the last weekend, where you can see the event and what we are going to do today. So let's start by sketching everything that we need to achieve this. In Show Cockpit, of course, you will need one element that will connect to the StreamDeck. And as I said, they were using MA2, so we will need an MA2 element in our project. As I said before, MA2 was speeding out ArtNet for the machines, and we added an extra control channel, dimmer channel, simple dimmer channel, which was also outputting every time an effect was being triggered. So we were capturing this ArtNet in the ArtNet in element. If you look at the documentation of the ArtNet in, it will give you whatever channels you want, but it will give you them as faders and not buttons. So we will need here the fader to button element, fader to button. So we can define a threshold in the whole range of the fader and translate that to a button. Whenever the fader goes above that threshold, it will be pressed, and when it goes down, it will be unpressed. Then there are two new drivers coming out really soon on the next 3.4 version. It's the version that I will be using here today. They are called countdown timer, and there's also a counter for integer numbers like the confettis trigger. It was not time, it was really 3 triggers left, 2, 1, and 0. So the fader to button connects to the countdown timer, which will count down the remaining time for the artist. And then if we were to connect directly the StreamDeck to MA2, like this, on the mapping, there's a problem, which is you are not taking into account the time left that you still have available. So you need some logic in the middle. And that's why we added a Lua script element here. Let's call it the Lua exec for executors. So the Lua is running on the background and listening to all the buttons of the StreamDeck, and whenever a button is pressed, it will get information from the counter, and in case the countdown, the remaining time is more than 0, it will trigger the executor. Alright, so we needed something else. So we needed, you remember the request was that the StreamDeck was also displaying the remaining time. You can see that on the video here on the right. When the button is pressed, the time is constantly updated on the button, and when the button isn't pressed, the time stops. And to achieve this, we used another Lua script. Let's call this Lua screen, because we are going to update the StreamDeck screen. It's also constantly running and checking the timer and sending that overlay text to the StreamDeck element. So this is getting kind of complex. Last but not the least, as I should have mentioned before, each artist has some time of effect available for his gig. So artist 1 may have 10 seconds of fire, artist 2 may have 30 seconds of the fire effect. And to manage that, we added another Lua element, let's call it Lua reset, which would then set the countdown timers. Okay? Here I only have one. I'll leave you for as a homework after I'm finishing demonstrating with just one. I'll leave you for the homework to try it yourself and see if you can add multiple timers and multiple counters. So this is the project that I'm going to demonstrate now in Show Cockpit. I have here a StreamDeck with me on the right, and based on this sketch, I will be going through step by step how we managed this to achieve this. So let's start by creating a new project. It will come out as empty as usual. And to start with, we will need the StreamDeck, the ElGato StreamDeck. Make sure your device is correctly selected here on the right. As I mentioned, we were using Grand MA2, so we'll need an MA2 driver as well. Use your credentials and connect. We are now connected to Grand MA2. What else do we need? ArtNet Input to get ArtNet from the MA2. So external control, ArtNet Input. Select your IP address. I'll select this one. And your channels, of course. We are here starting on channel 1 for this example on Universe 0. With 10 channels, we will only use one, but let's leave it like this so we can enable it. We will need the utility control convert fader to button. Well, let's leave it 3 buttons for this purpose. We will need the countdown timer. So in the next version, which will be 3.4 that I'm demonstrating here, it will be released really soon. You'll have these 2 new drivers. One is countdown timer and the other one is counter. We will add the countdown timer, enable it, and that's it. The rest, if we come back to our sketch, we already have these elements: StreamDeck, MA2, ArtNet in, fader to button, countdown timer, and the rest, the remaining, will be the Lua. It's the most exciting part. So let's start with the one that will execute executors or sequences on MA2. So this one here in blue. Okay. So if we come back to here to Show Cockpit, let's start by adding a Lua script element. If you double click it, you have here on the left your script. Okay. It starts with a sample code which just prints a message, waits for 1 second, and then prints bye-bye, and that's it. In our case, we will be firing executors. So I've prepared here, so that I don't waste too much time here on the video, I've prepared here some code. Let's start by the actions. So this code is basically creating a tree, okay, in a variable called actions. And inside actions, we will have all our StreamDeck buttons. And for each StreamDeck buttons, we are assigning some properties. One is called exec, which is the number of the executor in MA2 we would like to trigger, and the timer that we were using for this executor. In this case, we only use fire for an example. Okay, after this, here on the right, in case you don't have access to Lua scripts, this is a pro feature, and this is why I'm taking longer to demonstrate here all you can do with it. On the right, you'll have the function reference for all your elements in the project. If you select, for example, Grand MA2 and pick here on this drop down, you will see all the functions that you can trigger on the MA2 element in your project. And if you select one, for example, get executor appearance, on the bottom you will get some example code which you can copy and paste to your script directly, so that you don't have to consult any online documentation. You have everything offline ready to go. So of course we will need this element, so we'll get the Grand MA2 element to a variable so that we can afterwards call some functions from that. We will need the StreamDeck, so if you select the StreamDeck, whatever function, here you have the example code for the StreamDeck element, and we will need also the countdown. Countdown timer. All right. So to start with, we will start by creating an infinite loop. We can do this with a while true do and then end, and inside this while this will run until you stop the script. So for each cycle, you can start by getting the countdown timer remaining seconds. So you get remaining seconds, and in this case, in the example code, we will get the remaining seconds to a variable called v. Let's call this fire count, for example. And then we'll go through all the buttons on the StreamDeck. We can do that with a for loop. Sorry about that. So if we write for, let's have a variable for each iteration, I equals 1 until 15, because we have 15 buttons on the StreamDeck, do and then end. And here inside, I will give you this trick. You can get the row and column from this I variable with this code. So in row, we'll have, for the first row, we'll get 1. If we are going to button 6, this will have row 2 and call 1. And based on these two variables, we can then construct or concatenate some strings and create the correct button name, which will resemble the ones that we are using here. And of course, they will also be the same that are shown here on the mapping. So these are the controls provided by the ElGato StreamDeck driver, and these are the ones that you really need to use because you cannot change those. So after we have the button name, we can now really exit the code here so that we can see what this is doing. If we run the code now, save and run, we are basically starting the script and then aborting, because we are not doing anything with that. We are just setting some variables and then quitting. Let's print the button name here. So if you use the print function, and inside the parentheses you put a variable, this the value stored in this variable will be printed here on the bottom. So if you run the script now, you will see that for each iteration you will have a print here on the bottom. So this is working correctly, and this is how you can where you can see if your script is correct so far. To get the state of a button, we come back here to the ElGato StreamDeck and then get last value button. And if we use this function, let's call it button press. And here, in this case, the control name will be the one that we built before. It's called button name. So we'll use this name to get the value of the button into another variable called button press. And now we can print button press. And let's sleep for 1 second. Actually, let's print the button name. And then double column, and then press state. Save, run. So we have here the first button. Okay. So if we come back to the last button and press it while this is running, once we get to 3.5, here is 3.5 at 1. So now comes the hardest part. I will give you the code right away, so that we speed up this process. I will copy the code and I will explain it. So copy, paste. Okay. So where were we? So if button press is not null, so if something is on this variable and there's also some action for this button name, so if the button name is valid and here on this table, then we'll check if the button is pressed. If button press is more than 0, we set the variable to a boolean as true, else we set it as false. Here we are just getting the executor number from the table above based on the button name again. So button name, so actions, button name, exec. This is following this tree, so actions, whatever button, and then the exec. This will get this number, for example. And then we will check if the exec is running because we are storing it. And in case it is not running, we set this to false. In case we never run this, we set this to false. Otherwise, we get the last value. We are basically storing the last value here on exec running. We'll see this on the bottom. And here we are getting the timer variable, which is right here, okay? We in this case, last weekend we had one for fire, one for CO2, and another one for confetti. I will use just fire in this example so I can clean up a bit the code. So if timer is fire, then use the fire counter, which is our variable fire counter here, which is basically getting the remaining seconds for our countdown, okay? And now that those remaining seconds are in this variable called counter, and if counter is not null, then we do something. This is basically, let's clean up the prints. This is what is actually executing the action on MA2. So we are pressing the executor button, or we are unpressing the executor button. All right. And that's it. Let's take out this exit, and actually I'm going to undo so that we see these prints on the console. I'll just take out the exit, save, and run. So if we press now a button on the StreamDeck, we will see a go here when we press it, and we will see a button unpressed message when we release the button. And this basically means that the Lua script is running and it's working correctly. And in fact, it is already triggering the grandMA2 element through this functions over here, button press and button release for the exact number, which we configure here on the top. All right, so now coming back to our sketch, if you come back here to the sketch, this is already done. This first Lua script that is basically executing, and the other ones are pretty simple. Let's go down to the Lua reset script. So let's create another one. Sorry, let's create another one here. Lua script. Let's call it Lua reset. Sorry, let's call it Lua reset, right? And for the reset, it's quite simple. Let's create again a table, and this time it will be a table that will have all the times for all the artists. Okay. So this table is called artists. Inside there's an artist 1 and an artist 2, and inside each one you have the time available for CO2, fire, and number of confettis available for each artist. This function is just basically sorting the artists per name, because tables in Lua are not ordered, so they can come out in a different order. And now we are again going to need the get element for our countdown. So countdown, select whatever function just to get the example code. And if we copy this to our script, now we have the element here in this variable, our countdown timer. Remember that this name over here must be the same name that you give to your element. So if you rename this element, you will need to update your Lua script, which is an important note. So in this case, we will want to have a prompt when we run the script, a prompt with the selection for each artist. If you come here to Lua help on the right, you can see that there's a example for prompt with a drop-down list. You can, let's just copy this and change that to our needs. So copy and paste. Let's create a prompt. This will be the title. So select artist. That's the text, select the artist from the list. This is basically creating the prompt. The variable is called test. Let's leave it like that. Its type is dropdown. The options available will be the output of this function. So we'll just get this, get the output of this function and use that as the drop-down list options. We can just leave that. This is the default artist. We'll leave that as blank, and then this is going to show the prompt, and once the user clicks OK or cancels, the result will be in this variable. So if we run this now, here is our prompt, and here are all our artists on the table. So if we select artist 1 and click OK, the script is printing the selected option was blah 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 exclamation point, and the selected option was artist 1 indeed. So this variable here basically has the name of the artist name, this one. So you can clear out the print, and then how can we get the time, hours, minutes and seconds for the artist? So hours will be equal to artists artist's index will be the artist name. So we are entering one level inside the table. So imagine if we selected artist 1, we are now inside artist 1, and then we can select dot fire, for example. And let's take the first one. The first one is hours, as we commented here. You can change this however you want. I think it makes sense because it's the same that we normally use in timecode. Hours, minutes, and seconds. So hours is the first one. Minutes will be the second one. And seconds will be the third one. So we can print now. Just to make sure. Time left will be hours, and then column minutes and seconds. So if we now run this, we select artist 1, it's now printing 0, 1, 30, and indeed we have for fire 0, 1, 30. So it's working correctly. We have all the variables that we need now to set the time for our countdown. If you select here again on the reference your countdown timer, you will see that you have a reset to function, which you can assign to any button that you want in the usual mapping way. Let's assign it to, this is why we are using the button click suffix for the function. And if we copy this, it is expecting the hours in the first parameter, minutes in the second one, and seconds and the last one. So if we save this, now if we run, when we select the artist one, we will see that our countdown timer, we will have 90 seconds, which is 1 minute and 30 seconds. We can also open a window over here. And if we run the Lua reset for artist 2, this will change to 65. And we can confirm that by opening for artist 2, it is indeed 1 minute and 5 seconds. So our reset script is already working. So this is also okay. Finally, I will explain how you can use also Lua for the very last thing that we need, which is to display the countdown in your StreamDeck. So let's come back here to our project. Let's create another one. Let's call it Lua screen. And this one is pretty simple. This one is the simplest one. Although it seems it could be very difficult, it's actually pretty simple. So we need the ElGato StreamDeck again. And you will see again on this version 3.4, you will have a new function on the StreamDeck called set overlay text. We will just copy this, all this code here. So it gets the StreamDeck element into a variable. Here are the preparation of all the parameters to call the set overlay text. So you can set the row and column of the button that you want to use, whatever text you want to display, the color in HTML format, and the size. We can actually run this. This is setting the overlay text, but you will need to actually call the refresh function. The refresh function will actually send the image to the button on the StreamDeck. So if we save and run this, it will hopefully display Hello World here. I'm not sure if you can see that, but it's displaying Hello World in the first button. If we change this to Hey and increase the size so that we can see a little bit better, save and run, it changed to Hey. Get this a little bit closer to the camera. Yeah. And you can also play with the color, etc. For this purpose, we will want to get the remaining seconds for the countdown. So again, select countdown timer and then the get remaining seconds to get a nice example code. Let's get this to a variable as well. Let's start by getting the remaining seconds. And we will store this in the V. Alright, and our text will be V. Or we can just put get remaining seconds here on the bottom. So ptext equals the remaining seconds, and then we use the parameter text here on the set overlay text. Save, run, and there you go. You can see 65, which is indeed the remaining seconds for our countdown timer. But there's a problem with this script right now. It runs when you make it run, and then it stops. But we want it to run continuously. That's why we are going to include this while loop. So while true, do all that, and here, let's indent so that when we look at the code, we see exactly what's inside the while loop. And let's give the CPU a break, so we are not going to 100% CPU, just refreshing this image. So sleep for 0.1 seconds, for example. And there's an extra thing that we need to do. Because this remaining seconds can come as null value sometimes. What we will do is set this to a variable. If v is null, then do nothing else, do all that, and so we will not do anything if the remaining seconds are null for some reason. So if we now save and run this, our screen is constantly showing the remaining seconds for the countdown timer, which is now 65. I'll try to get your better view on the StreamDeck, at least a little bit bigger. Okay. Hope you can see better now. Where were we? If we come back to our sketch, we already have everything. So we can start mapping. So the Lua script is already picking whatever comes from the StreamDeck. It's reading directly the countdown timer. It's triggering MA2. And those are connected. This is also connected, so we are already resetting the countdown timer. The screen, the Lua screen, is taking care of these two connections. And there are 3 remaining connections here on the right that we will map now. So map MA2 to ArtNet Input, this one. The ArtNet Input to fader to button, and then fader to button to activate the countdown timer. So if you come back to the mapping page on Show Cockpit, let's start by selecting MA2 here. Actually, there's a mistake because the connection here between the MA2 and the ArtNet Input is actually ArtNet. So this is not a mapping that we need to do on Show Cockpit. We are outputting ArtNet from MA2, and we are capturing ArtNet using the ArtNet in element. So in this case, we only need to connect the ArtNet input on channel 1 for the fader to button. Let's assign button number 1 to channel 1, button 2, button 3. So this is the ID for the fader to button element. Each button should have a different ID, of course. And now we will need to connect the fader to button to the countdown timer. And we will use the hold run function. If you read here the documentation, it says starts the countdown if button is pressed and stops when the button is unpressed. This is exactly what we want to do. Let's do this for button 1. So our channel, our ArtNet channel 1 will trigger this virtual button on the fader 2 button. One whenever it is above 60%, I guess. Yeah, above 60% will trigger it. When it goes below 40%, it will unpress it, and this will then trigger the run for the countdown. So indeed, if we here is MA2. I did this previously. I have 3 dimmers set up here in my patch. Each dimmer is one DMX channel, channel 1, 2, and 3, which are the ones that we are listening to in our ArtNet. And I have here 3 executors as flash. And when I flash the first one, our StreamDeck here on the right is actually capturing that ArtNet. And when the channel goes to 0, it stops the timer. And it is also true that if our Lua script for the executors is running, we are actually using button 1 here on the StreamDeck to trigger that same executor, executor 101. So if I click this, my Lua script is going to activate the MA2 executor, which will then set that ArtNet channel at 1, and then we capture that ArtNet channel in our ArtNet Input element, we convert it to a button, and we use that virtual button to count down the time. Then we have this Lua screen that is basically continuously getting the remaining time for the countdown and sending that to the StreamDeck. And this is basically it. What you can do after this is create some images for your buttons, so that when you handle the StreamDeck to someone, that person knows exactly what that button is going to do. You can also have some feedback. You see here on the video on the right, when the user presses the button, the feedback on the button changes from red to green. That is actually pretty simple to do. I will also explain how to do that. In this case, because we didn't do any mapping between the StreamDeck and MA2, we are not getting any feedback, and our Lua script is not able to give any feedback to the button. This is why we'll need an extra utility driver here in the feedback section. You have one called button flash feedback, and this is a very dummy. That's why it's free. It's a dummy driver that basically, when you connect a button to that, when you press the button, it will send a feedback as on, and when you unpress, it will send a feedback as off. So we can also connect our StreamDeck buttons to that button flash feedback function called button connector. Again, the button connector identifies each button with a different ID, and when you assign one to the StreamDeck, it will automatically increment. You will need to make sure that every button has a different ID. Otherwise, when you press one button, you will have feedback on more than one button or in a different button. All right. So now that we assigned, we can go through all our buttons. And that's it. So now it's green when I press it, and it's red when I unpress it. If we double click here on the StreamDeck and edit on, off, and initialization, we can change these colors, and we can also change the image that is shown above the color and below the overlay text. So you can overlay there something like this on the video, like CO2, fire, the type of effect that is going to run, etc. So this was the use case for this Q&A session. I don't know if there are any questions on I will check now the chat. Sorry, I was a little bit focused now on the tutorial. Okay. So Dennis, love it. Very interested in StreamDeck with Resolume video thumbnails. I will note that down because that's actually pretty good feedback. I'm still unsure if the Resolume is able to get you thumbnails through OSC, but I will check that. Resolume thumbnails to StreamDeck. Note down. And there are a couple of friends that is messing with me and with my hair last week. I had a haircut. So if there are no more questions, I will move on to the questions that were asked last week on Facebook group. One is by Christian Jackson. He asked if it was possible to select the Resolume clip based on a single DMX channel. So use the value, the output value of a DMX channel to select the clip number. And that's actually possible. So to do that, again, we will need external control ArtNet Input so that we receive DMX. We configure whatever options we need to configure. We can enable it. Then we will need to control video Resolume Arena. Again, set your input and output ports accordingly. I will actually start our arena here on my computer. Okay, let's rescale so that you can see everything. Take out the audio and okay. Oops. Okay, so arena, I will make sure that my preferences are okay because I'm really not sure. Yeah, incoming port is 702. So this is not correct. All right, arena, let's disable arena. So outgoing from show cockpit, incoming in arena is 7002 and the other way around 7003. And now we should be connected. I'll also, just for debugging purposes, add here the StreamDeck, which is already connected to the computer, and try to map the trigger clip 1 and 2 from the ElGato buttons. So if I now click on the first one, I'm on the first one, here on the second one, first, second. So the connection to arena is working. So I can now get rid of the StreamDeck now. And the question was, can we use the ArtNet input and a single DMX channel to select the clip on your on a layer, on a single layer? And this is basically to use as few parameters in MA2 as possible in Christian's case. So we have a new utility somewhere. It's called fader to selector. Okay. We will use just one for this purpose, and we will connect the ArtNet input channel 1 to the fader control, and we'll set the maximum level to 255, which is the maximum in DMX. And now if we change the value here on, let's move this to a fader. Let's use the first one. Okay. I think it's better actually to use the programmer, as we can see exactly the value. So this is in percentage. Show absolute on. I think we should be seeing the decimal. Okay. So we'll use the first one to select the clip. All right. If we come back to show cockpit, we already connected the ArtNet input to the fader to selector, and if we set the log level to verbose, and you change here the value, you will see the selector 1 changing the value. Now it's at 8. If we increase, now it's at 11, etc. So this is actually working. We are getting a DMX channel and we are translating that to a selector type of control. And now it's really simple. We just need to connect the trigger select layer clip. We select the layer number and we can connect this to the selector 1. And now we will hopefully see that the clip selected here on layer 1, I only have 6, so I'll change this to ultra. Select 9, 5. Oop. 1 is, yeah. So it's 3 and it's selecting the number 3. Now it's at 1 and it selects the clip number 1. So it's quite simple. Reviewing everything, we get the ArtNet input, we convert that to a selector type from a fader to a selector type, and then we use that virtual selector to control the arena layer. That's it. Any questions? Okay, it's not a question regarding this, but I will note the question down. Another question that I was asked during this week was if MA3 is going to be supported. My answer must be yes, I want to support MA3, but it's still not out. I've been doing some tests on a full-size MA3, and their web remote is quite different from the MA2 one. So if it will be possible or not will depend on it has changed a lot since the first time I checked it. So they are still developing it. Once it is stable, in a stable state, I can start looking at it in more detail and check if we can integrate MA3 here in Show Cockpit. Of course, I want that. Everybody wants that. It's the top one requested driver actually, although still not out. I will do my best. That's what I can say now. All right, so I'll close a few things here. Bye bye Resolume. And bye bye MA2, because we are now going to open Onyx. Because the following question is how to control VLC from Onyx. And although I didn't try this before, I have VLC here. Okay, let me just check one thing. Because I don't think I have any files in this. I'll check really quickly if I have some files here on this computer. If not, I will just explain and you'll try it yourself. Okay. I think I found here. think I found here. It's actually a tutorial. Let's just use that. Has a tutorial for the trackball. It's an example for using trackball in MA2. The video doesn't really matter. What we are interested in is controlling the play and stop, etc. So the first thing you need to do is going to preferences. Let me just do one thing here. Let's start a new project, VLC Onyx control. Let's clear this out. All right, so to start with, you need to go to preferences, I guess. And then you need to show all settings. And there's a setting here that enables HTTP control. Advanced network, no. Here it is. Main interfaces, HTTP. So you need to enable this one. It's already enabled, so it seems. Let's start by adding video LAN VLC HTTP. This is the IP address. Password. Good question. Good question. Blue HTTP. Set the password here, okay. Set the same password here and connect. Okay, we are connected now. And now we can, again, let's use the StreamDeck since it's here. Let's use it to test the transport control. So I'll use first button as play, the second one as stop. And now it's stopped, play, and stop, play, and stop. Yeah, you can also use pause, resume, next, previous. These are the ones that are available. You can also full screen, scroll through the loop options, and also the repeat options. So our connection to VLC is okay. We just tested it using the ElGato StreamDeck. Let's delete it for now. And I will actually create a new, in Onyx, create a new show, blank show. And we will, of course, need Onyx element in our project. So I will add it now, lighting, elation, no, Obsidian Onyx. Connect it. Okay, so now again, I will say it again. The question is, you have I don't like this color. You have Onyx. And you have VLC. And there are a few ways of controlling VLC via Onyx. One is through ArtNet and do the same as we did before. So the first one is actually ArtNet out of Onyx. Then in Show Cockpit you add the ArtNet input. Then we convert a fader to button. And then we can connect to the transport control as we just did for the StreamDeck, to play, to stop, pause, etc. However, there's a better way, in my opinion, to do this. If you are running the Show Cockpit in the same computer as Onyx, you can connect this directly. Okay? All you need to do is create an external macro in external macro in a cue list, okay? And that will generate, when you run that external macro, it will generate a virtual button event, and you can connect that virtual button directly to play and pause. So let's start by coming here to the playback buttons in Onyx. Sorry, you're not seeing anything. Here in Onyx, we will create a view here in the playback buttons. Let's record an empty cue list here. And we can call it, all right, it's easier now to just remove it and rename it like this. So let's say play, and done. I don't have anything in the programmer, okay? It's just a cue list and a blank queue. And pause and stop. And now we will edit each of these cue lists. Let's start with the play one. It's been a while since I've used this. Okay. Here in cue list values, you have the Q1 from the play cue list. You can expand this so that we see no. Okay. You can enter edit mode, add a macro on the first cue list, and here you select external macro and you use a number. Let's use external macro 1. So play will be external macro 1 for the playback. Now we select the pause. If we come back to cue list values, we can add a macro to the pause Q1, external macro 2, apply. So when this queue runs, it will run the external macro 2. And for the third one, let's add a macro and select external macro 3. Right, so when you press play, pause, or stop, whenever you press one of these buttons, you are essentially generating an event here on Onyx. Please have a look at these indicators, element indicators. When you press play, pause, stop, play, pause, stop, play is not actually working. Okay, I'll need to check that later. External mic, let's change the external mic to 4 just to try it. Release it first. Go. Yeah, so it's working. Yeah, it's working. So let's change it back to 1 to keep our logic. So play, you see in a control event, your control event. You can also actually change this to verbose. And if you trigger play, for example, you'll see here the external macro 4. For some reason, it's external macro 4. I think we've changed that to 1. It seems to be a bug actually, but okay. Here, external macro 2. Let's release and go again. Now it's 1. Okay, so it's definitely a bug in Onyx side. So you need to release it and then play it again so it updates. So you have 1, 2, and then external macro 3. This will also appear in information. So 1, 2, 3, 1, 2, 3. All right, so what you can do now is connect the Onyx here on buttons. You'll find all the external macros up to 100. And we can use play for external macro 1, stop to external macro 2. Pause was external macro true. So click here to edit, change it, click it again, and it's changed. And now stop will be external macro 3. So now I have here VLC again. Let's play. Yeah, it works. It's playing, as you can see. Sorry. Now it's playing. Let's pause it. Let's click it again to resume. Pause. Resume. And then stop. And it stops. So that's it. That's how you can control. I think this is the best way to control VLC from Onyx directly, because you don't need to rely on ArtNet and ArtNet configurations if you are running this on the same computer. Let's continue. Thank you for the questions that you have been asking on the chat. I will get to them one by one. If I don't have time to get to them today, I will later. Okay, I'll get back to you. So I'm noting down all the questions so that I don't miss anyone. And this was how to control VLC from Onyx. So uboy86 asked, is there a way to assign a button of a controller to change pages in Playback window of Onyx? Unfortunately not. If you see here on the mapping, when you try to connect something to the Onyx Playback button, you always need to set the page number here, unfortunately. If you want to add some logic, again, this is fixed. You cannot add anything dynamic here. You select here the page number, you assign it to a button. It will always be that number unless you change that here in the mapping section. If you want to add some logic, you can use Lua script for that. Okay, so you can have a variable and then use a Lua script to trigger on a page depending on the last page that you set in that variable, if that made sense. If it didn't, please write something on the chat and I will explain that by example. And the second question by uboy was how does the parameter scroll works in Onyx? Please show an example. All right. So parameter scroll. If we select here the parameter scroll, directly controls a parameter. Here you can set the parameter name. If you click here on parameter name, you can see some help, which I must admit is not very helpful in this case. But you can basically set any parameter here that you see on the parameter here on the bottom. I will have to patch something for the sake of this example, so I'll patch just a channel, auto patch, apply. Okay, so fixture number 1 is just a dimmer channel. And if I select it, fixture center, auto, okay. Let me just record this to a group because I may have to select it again, okay. So here you have intensity. This is the name of the parameter. And the parameter scroll is a way of setting the value of this parameter by scrolling it. Not the direct parameter, you can use it to set the value directly, okay? And the scroll is used in encoders because if you have a fader, you have a minimum and a maximum, you can set the minimum and the maximum of the parameter. If you have an encoder and the parameter scroll is an encoder type of function, give me just a second here. I will show you the documentation. Alright, so if you open the Show Cockpit website and you scroll down to check available drivers, you'll see all the drivers, and you have here Onyx, and here you have all the functions, and you can see that the parameter scroll accepts faders, encoders, and axes, and it can also be triggered by Lua as all other functions. But it started as just an encoder type of function. If you assign a fader to that, it will use relative to the center. So if your fader is above the center, it's the same as if you were rotating your encoder to the right. And if you are below the center, it would be rotating the encoder to the left, hence changing the parameter that you select. So I may have here a controller with encoders. Let me just get my Akai APC40, just a second. So I was not expecting to use this device today, but since there's the question, I will add it because you asked for an example. And I was only prepared with my APC Mini and Innovation Launchpad, but these only have faders or buttons. So let's connect this to USB and add our element here, external control, MIDI, APC40 MK2. Select it on the list. Sorry, I need input and output, of course. Okay. It would be nice if you could also see this. What I'm doing here on the controllers. Space is getting a bit cluttered. So, all right, let me arrange here the camera. So here's the encoder section, okay? If you set this to information level, and if you rotate this first encoder, you will see how much you are rotating here on the bottom. So if you rotate it right, it will display rotate 1. If you rotate it to the left, it will display rotate -1. Because this is an encoder type, it doesn't have a minimum and a maximum. You can change this to, if you double click APC40, you can change this by clicking in these buttons. There's one button per encoder. These are the device control, and the ones above the faders are the track knobs. You can set them to either fader or encoder types, and there are also other types like pan and volume. That has to do with the LED feedback on the actual device. So if you connect the APC40 encoder, select encoders here, I will rotate to identify here on the list. It's device knob 1, and I will connect it to the parameter scroll, and I will use intensity as the parameter name. This is the scroll amount. We can fine tune it later. Let's leave it at 1 right now. So now when I rotate it, I expect that my intensity goes up if I rotate it right. Okay. If I rotate it left, my intensity will go down. If it's going too fast, you can change the scroll amount here to a lower value. Okay. Let's try 0.4, which is lower. Right. Now it changes a lot less. And if you increase it to a bigger value, of course it will rotate faster, as you can see here. All right, and that's the example for the parameter scroll. if you set it to a fader, as I said before, if your fader is in the middle, it will not change your parameter. If your fader is above 0, is above the center, it will rotate right, and the more you go up, the faster it will rotate right. So it basically emulates an encoder rotation based on the position of the fader relative to the center. All right, I hope I answered your question. Next question, is there a way to select groups in Onyx and deselect the others with feedback in Akai APC40 MK2? All right, glad I just unboxed it for this one. So you want to select groups in Onyx and deselect the others with feedback in Akai APC40 MK2. Let me think about that for a while, because my first reaction is usually, maybe because I'm a programmer, my first reaction is usually do it with a Lua script. I'm just thinking if there's another way that you can do that without using Lua. So you can select the group, of course, but you cannot unselect the group. That's the problem. No, you cannot, because you cannot unselect the group or deselect the group. So the answer has to be Lua script. And let's do that with Lua script so that I explain also the feedback thing that you want. So, okay, I'll try to zoom out a bit so that we see the buttons here. Okay. So let's use the first row to select groups. I will first need to, of course, patch some more fixtures on the show file. Let's patch 7 more because we have 8 columns. No, just get back. Okay, so first one, next record 2, next record 3, next record 4. So yeah, so if you connect to the select group your pads, so this is pad 1, yeah, group 1, 2, 3, 4, it will hopefully select your groups, but it will not give you any feedback. That's okay, we can fix that, but it will keep all the other groups selected, which is not what you want. Okay, so let's do a Lua script for that. I will remove all these assignments, and I will add a utility Lua script. We can call it a better name, like select group. Okay. So we will start by selecting Onyx here to see all the functions that we have available from Onyx, and we have here the select group. Let's copy the example code, and this example code is selecting group 1. So if we save this and we clear our programmer, when we run this Lua, group 1 is selected. So this is just to confirm that nothing changed in the new version in Onyx. So the select group is still working, and there's another one I think called deselect. Deselect. Oh, there's a deselect fixture but not group. Okay. no problem. Let's deselect all, since we want to. This will deselect all the fixtures, so it will also deselect the group. Let's comment that line and call it like this. And we see the group gets deselected. So the first thing that we want is to deselect everything, and then we select the group that we want. But we want this number to be dynamic. We don't want it to select always group 1. We want you to set some variable and then use that variable here. Let's call it group num. Okay. Save. And now when we go to mapping, we can select the Akai here, the buttons, and you can execute the script and pre-execute group num equal 1. So this will be executed before the actual contents of the script that you have there. So we will set this variable at 1 and then run the Lua script, which will use this variable. So this will be group 1, this will be group 2, and this will be group 3. When we click the button, we will execute the Lua script, but before we will set the group num variable. And then the Lua will select the group based on this variable. Let's see if it works. Yeah, shall we? So group 1, group 2, group 3, 1, 2. Actually we have 4 groups, so let's just be consistent and add a 4 group here. So if we select that Onyx, yeah, 2, 3, 4, 1, 2, 1, 4, 3. So it now selects just one group. And the second part of your question was regarding feedback. As you know, we are just executing the script, and the script does not give any feedback to the button. So we will need to create it. In this case, because we are doing the toggle thing, there's a utility here called button groups feedback, which basically groups a set of buttons together, and only one will have the feedback, and the one that will have feedback is the last one that we trigger. So let's enable this, and we'll need to map our paths to the buttons group feedback. Button connector, let's use group 1. We will only have one group in this example, and each button again needs to have a different ID. So click, 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 click. So we will execute 2 things. We'll execute the script, and then we also will trigger the button connector on this button groups feedback element. And hopefully when you click one, saturation is not allowing us to see anything. Let me try to correct that a bit. Just a second. With what? With the gain. Gain is also saturation, brightness. You almost can't see anything. Exposure. Okay. Now we have the first one green and the other one's red. And I will also show you Onyx, so you can see that everything is in sync. When you select one group, there's a small amount of delay because I have the webcam pointing to the device is not running on the same computer that is running Onyx right now. So the Onyx window is coming from a different computer through the network, and apparently there's some delay, but I can assure you, and you can also test it in your system, as soon as you click the button, the group gets selected in Onyx and you have instant feedback. I hope I have answered your question, Tiziano. There was also a question before regarding the global fade rate and global effects rate. That's a usual one in the Show Cockpit group, actually. In fact, you can control the 4 encoders. So if you select the rate group in Onyx, you can control this with an encoder. And again, there are here utilities that convert faders to encoders in the same way that I explained before, relative to the center. So above the center will be a rotation to the right, below the center will be a rotation to the left. So you can basically use a fader, convert it to an encoder, and then connect it to the global fade speed. More recently, you can also assign the global fade and global effects here to the screen encoders, and you can already map to screen encoders. So you don't have to worry if you are screen encoder. That's what it is. So just set the encoder number 1, 2, 3, 4. You don't have to worry if you are in rate group or grouping. Otherwise, you would think that you would change the global fade speed and you would be changing the swing of the effect, for example. So that's what I recommend. If you really want to control it with a fader, you can. That's the best I can do. Andrew asks if there's a way to select a specific parameter page, not parameter group 2. Example, have dedicated color and pan and tilt page buttons. No, it's unfortunately it's not possible. So what you're saying is always have control of intensity. Well, you cannot control the parameters, but you can control them directly. So if you use here the direct parameter, or the parameter scroll, as I explained 20 minutes ago, the direct parameter you cannot control color apparently, but the parameter scroll allows you to select anything. So if you write red, you will be able to change red with an encoder. You can also again link the fader to an encoder, and then you have instant control of red, again green, blue, etc. Or is the parameter encoder thing you just did before the best way to achieve? Yeah, I think so. I think this is the best way to do it. Alright guys, so it's been 1 hour and a half already. I think we are quite long in this journey. I hope that it was useful for you. My idea is to have this kind of live sessions once in a while. So keep participating in the Show Cockpit group on Facebook. In case you have any configuration questions, that's the right place to ask your questions. And see you on the next tutorial video or in the next Q&A session. Thank you and see you on the next time.